Hi everyone, are you able to hear me and see my screen clearly? Hi Abhinav, hi Balaji, hi Bintao, hi Kamal, hi Noor, hi Prateek, hi Shahrukh. So uh, you can increase the volume of your laptop so that you can hear me better because I'm going to talk at this pace today. My throat is a little bad, so I'm going to talk at this pace. And so I would suggest that you increase the volume of your headphone or the laptop. All right. Is the voice clear to you? And is this okay for you? Or do I need to speak louder? Great. Great. All right. So great. Apologies for yesterday's cancellation of the class. And so we will continue our end-to-end machine learning project. Again, this end-to-end machine learning project makes you ready for most of the machine learning challenges that you'll face. And my strong recommendations would be that as soon as you finish end-to-end machine learning project, you should start competing on Kaggle. Okay, again, to all of you. So this end-to-end machine learning project is going to take you through the entire machine learning cycle. And just after this one, you should start working with Kaggle. A project at Kaggle or compete at Kaggle, or maybe you can form the team from the class itself and start working on the problems at Kaggle. What is Kaggle? Kaggle is a place where people post the challenges and other people need to solve those. Okay, so it's a very important project that we are doing right now. It might look It might look as if we are going really slow, but it's a very stable way of learning. Okay. All right. So the so once we finish this, I'll guide you, and you can pick up a couple of projects from there, and then start working on that. Okay. So all right. Great. I'm going to do a very super fast recap. All right. So it was a complete, so we set up the environment and we, the objective was to build a model of housing prices. And this is how the data looked like. Then we loaded the data. Then just to show you how it looks. So next is we look at the big picture. And this is where our model is going to fit. Okay. And then we framed the problem. We checked the current solution. Then we got the answer that the typical error rate is 15%. And we understood that we are going to do a supervised regression task. Okay. And we're going to go with batch for now. Okay. Select a performance measure. Then we talked about root mean square error. Then we went to statistical inference, talked about probability, talked about probability distribution. We understood we understood the histograms and understood the modalities, understood the box plots, then understood what it is mean by center. Then we learned that median is a better central tendency than the mean. Okay, so yeah, then we measured the spread. Okay, no worries, Nirav. It's okay you've joined late. We are just doing a recap. All right. Uh, so we talked about spread, and all right. Then we also talked about an important here. We we talked about a situation where we have the scores of two persons in different exams, and how do we compare those? This idea will come back later in the current project when we are measuring the performance of our algorithms. That point of time, we will learn that the same strategy we will also apply there. Okay. Now, coming back here to the root mean square error. So when we are predicting something, we compute the overall error by summing up squares of differences from the actual. Okay, so we build a hypothesis, or we kind of try one technique, we will find the error in that technique, and we'll compute the overall error as a single number. Okay. Okay. So then we looked at the data. We started exploring the data. We there was we tried to understand what does it mean by fitting a line, and we talked about how to fit the line. Okay. And when we are fitting the line, this is the error, and the overall error is computed by summing up all such values. Okay. Then we understood that the line with the minimum root mean square error is the best fit. Okay. Now we started with taking a look at the actual data. This is how the actual data look like, and we plotted the histogram of the data, and we figured out that there were the data is capped, and there is a long tail. Okay. Then the second thing which we did was how to create a test set right now. This is an important aspect of the overall project. The idea is to create the test set in the beginning before we start to peep into the results. Okay, and this is called snooping bias. You will end up seeing the entire data and end up skewing your model in order to just fulfill the current test case. Okay, so to avoid that, we should just split the test and training data right away. So first thing we did was we splitted the data based on not so random seed, as in we provided a fixed seed, so that every time we run the program, we'll get the same permutation. And all right, the other thing that we discussed about here is, so here we are basically computing random permutation of the data, and based on a test ratio, we are splitting the data into training and test. Okay. Okay, so we talked about seed here, then we ran the function and we were able to split. Now, the problem with split test train function was that rows, since it was based on the record number, as in the number of record, it could it could get the different data set every time, different parts of the records every time. So we tried to we tried to identify an identifier in the data set, so that based on that identifier, we will pick the data set, so that even if the data is changing, updating, the older records having some identifier will always be going in the same set, whether training or test. A record which was earlier in the training set will not move to the earlier in a record which was earlier in training set will not move to the test set. This way, we minimize the total snooping bias, and we make sure that the algorithm that we train should not end up looking up at entire data, right? So we fixed a column, and based on that column, we selected it whether that column's value, based on the column's value, we are generating a number between 0 and 1. And based on that column's value, we are figuring out whether we should put it in testing or training. Okay, a testing set or training set, or test set or training set. Okay, so that's what we are doing. So this is what we did last time, and we splitted the data based on the ID. Okay, so and it worked fine, and so we created a function. So all right, so here we did something. Let me go back once more. So yeah, so then we selected the latitude and longitude as the ID, and that's it. All right. So there is a train test split function provided by scikit-learn that does a similar thing, just that it doesn't take the ID into consideration. Okay. So train test split data takes a data set, and you pass the test size, you pass the random state, just like we had the seed. In the same way, I just okay, yeah. All right, so this is where we were, right? This one, right? Yeah. Is this the one? Okay, so this is where we were till last point. Okay, so we were basically trying to split the data into test and train, and we learned a couple of important things till here. Okay, now moving on from here. All right, Nirav. So Nirav had recently joined, so he hasn't been able to go through the previous videos. So here, okay, so what are we trying to do is we are trying to analyze the housing prices in California, various districts of California. And for that, we have got the data set, and we are trying to split that data set into two that data set. One is called training, other is called test. Why are we doing that? So that on this data set, we the training part, we will do the training and we'll check against our results using the test part. Okay, so all right, so that's what we are trying to do. All right, so don't worry, you have not missed much, and the parts that you have missed you can always catch up quickly. So let's move on, and uh, it won't be we basically are try to understand how to split our records such that we don't have the snooping bias in the data. Okay, don't worry if you did not get this, just understand that we are trying to split the data, okay, into two parts. All right, so this is where we were, and we understood that here um, splitting data based on ID, splitting data based on ID was a good choice. Okay, let me shut down my existing Python notebooks. Okay, all right. So so the way you launch Python notebook is you go to CloudX Lab. Okay, and you go to my lab. All right, you open a web console. Open a web console, or let's just open Jupyter. Okay, my open Jupyter. It'll ask for the login password. Then here I said new terminal to open the terminal. Okay. Then I had done git clone this, right? Not this, git. Okay, basically the repository's name was this. Okay, so you need to do git clone this, git clone this. Okay, this is what you need to do in order to get the latest code. Okay, I hope everybody's lab is working fine. Then you go into the ML folder. Okay, and those who have already who already have this th this repository cloned, they should do the git pull. Okay, so as a habit, what I do is whatever I do, as soon as I get into the folder, I do git pull. Okay, git pull means it will get me the newer data. It is saying that your local changes to the following files will be overwritten by merge. So what will I do is I will say git checkout new one. So this will overwrite my changes. Okay, and git pull. Present working directory for me was the home directory. And right now in the home directory, when I did the clone, it created a folder called ML. I am in the ML folder in PWD. Okay. Okay. So, sorry, I think I gave you a wrong link. I will give you a proper one. Okay. So this is the URL that we are sending. Okay, so here when you say git clone, you will get this, and I think this is the right one. This is the right one. Here you will say git clone and this URL. Okay, I'm going to give you again. Okay, So git clone, the new one having ml.git is the correct URL. Okay. And if you have already checked in, so you do this as soon as you log in. As soon as you log in into terminal, you should say git clone. Okay. If you have already checked out, it'll say that ML is already existing and is not empty. Then you go into the folder ML and say git pull. If it gives error like you have made some changes, do git checkout on that particular notebook. Git checkout will overwrite your local changes. Okay, say for example, I make some changes, right? I'll show you that part later. So I hope everybody is comfortable till here. So first of all, log into the terminal. So what I did was I clicked on uh, I went to the lab. I clicked on Jupyter. Once I logged in, I get the file browser. Then I clicked on new terminal. It opened a new terminal. And there I cloned the repository and went into ML folder and then did the git pull. Yes, everybody is okay with this. Abhinav, Balaji, Bintao, Giji, Gopinath, Kamal, Neerav, Noor, Pavan, Pratik, Shahrukh, Tanma. Should we? Yes. So that means you have already the ML1, Tanmay. All you need to do is do a CDML. A question from Binta is, could you check your Python version? Sure. The Jupyter one should be having, Jupyter console would be having Python as in -v. Sorry, Python dash dash version. So this is in the Jupyter console, the Python is 3.6.3. If you are going to the normal console, there the version of Python could be different. Okay. Say if you are going to the normal console like this, okay, here the version of Python could be is 2. So what you need to do in this case, it's not required by the way, source activate py36 in the normal console. In the Jupyter console, it's already done for you. Okay. Yes. Never mind. So Tanmai's question is, what is the difference between normal console and Jupyter console? Jupyter console is actually running with Python 3. Therefore, it has already the environment set up there. Okay. In case of a normal console, we need to do this. Okay. In case of Jupyter console, before launching the console, we did this. Okay. So Jupyter console gives us the Python 3, while the normal console by default gives us Python 2, but we can activate the Py36 environment in order to get the Python 3.6. Okay. All right. I hope everybody's set up. So Tanmay, what you can do is, since it's already existing, okay, how do you stash changes? So stash changes, if your changes are important, what you can do is either you can copy this notebook into some other file, okay, or you can right. So let me, Noor, is it okay if you show the screen to others, because that error other people would also be facing? Okay. Nirav, are you able to log in into Jupyter and clone the repository? Okay. Just give me a second. I'm not able to see the screen yet. Okay. Yes. Can you try again? Yeah, I missed that part. Yes. So it's saying that there are these changes that you have done. Do you want to keep these changes, or do you want to um, let them go? Okay. So you copy that location. From machine learning slash. Yeah. Okay. Copy that. Now say git checkout, git checkout, and then paste that location. No, oh, I see. So control W, control W. You said command W. Okay. Okay, never mind. So just go to running Jupyter. There is a running Jupyter. In there is a tab called running Jupyter. Just click on the terminals. Yeah. Okay. So you say control W, not command W. Uh, okay. Oh, what's happening? Press control L, control L. Okay, let's do it from the beginning. Git checkout. And just say M machine learning. Just say M and autocomplete. M and press tab to autocomplete. Yeah. Then okay, press tab again twice. Yeah. So just select E and D and then autocomplete. Enter. Okay. Again do git pull. No, git pull. Git pull. Git space pull. Yeah. All right. So you have got the latest changes. There are some more files that have come in, and it works fine. All right. Thank you. Great. Are you able to see my screen? Let me just say share the screen again. Great. All right. So I think this challenge you all will be facing now. You can fix that challenge. Okay. Okay. Okay, Nirav, no worries. For now, you can just open the this one, this GitHub repository directly, and inside that you can go to the machine learning here, and you see the end-to-end project. This is the one that we are going to talk about. Okay. All right. Good. Good. So, all right. So what we just did was, um, we are basically doing the hands-on in something called a Jupyter Notebook, and in the Jupyter Notebook, we are keeping it centralized in a public repository at GitHub, And when anybody wants to use the notebook, they can just clone the repository and open that file in Jupyter. Okay, now since we have checked out here and updated our code, we can go back to files, and in the files you will see ML folder. Okay, you will see ML folder in files, then machine learning folder, and inside this, the end-to-end project is what we need to open. Okay, since we have checked out recently this folder from the GitHub, this should reflect in your home directory at CloudXLab. Okay, if you have checked out in the console of CloudXLab. All right, so and the way we execute code in case of Jupyter is by pressing Shift Enter. But in our case, since there are just too many things to run, what we will do is we'll go to the point where we are right now. Okay, so where are we right now? We are above this. We are above this, and we are right. This is probably, yeah. This is where we were, right? Last time when we were talking about this. Okay, so I hope everybody is clear. Or basically, we are trying to split the data based on a particular column instead of just random. Okay, that's what we are trying to do here, based on a particular column. So here we are passing the housing, the actual data. Okay, okay, this is the actual data, and then we're passing the ratio, as in 20% of the total data will become the test data, and 80% will be the training data. Okay, on the 80% of the data, we will learn and we'll apply that learning on the 20% of the data. And after splitting, it'll give you two variables, train set and testing set. So this function is returning two values, okay? And these two values will be used in the rest of the session. Say train set will be used for training, test set will be used for testing. Okay, and basic testing again will run algorithms on this train, which will generate the predictions on housing prices, and will compare the housing prices with the tested. Here, the index is the name of the column on the basis of which we are splitting the records. All right. So the function of hash, what is the function of hash? Hash basically converts any big number into not into impossible to guess kind of a number, which you can't guess what will be the output. And that's the function of, let's take a look at this function that we're calling. This is where we are defining this function. Okay, so we are defining this function first, importing hash library, defining this function, and defining this function. What does this function do is, based on this data, it picks up the ID column first. Then what it does is, for every record in this ID column, it is generating the hash. Okay, hash, as in here, if you go back here, so what it is doing is, for given an ID, it's generating true or false. Okay, hash converts anything into a fixed size, difficult to guess number. Okay, and then we are just picking the last bit of that. If that last bit is lesser than the sample space, we are picking it up. Okay, in simple words, we are splitting our data set using a particular column's value. Since that value could be anything, therefore we are converting that into a number, and then we are based on that number, we are we are either picking it up or ignoring it. Okay. So right now, yes, no exception handling has been done here. Okay. And since it's going to be mostly us right now, but later on, ideally we should be doing the exception handling because this code might go into production. All right. So don't worry if you did not get exact functioning of this one. Eventually you will get it. Right now, just understand that we are trying to split data based on a particular column. Okay, now it's saying the error that it is not existing. So why it's happening so? Because all of these data sets that we are using here, all these variables that we're using here, most of them have been defined above. Okay. So what you can do is you can say run cell above. Okay. So again, let me again define this. So we are using this function. We are splitting this data into two parts. One part on which we will train our algorithm. Second part on which we will test our trained algorithm. Okay. And how much would be training and test data? 20%, 0.2 means zero point 0.2 fraction, as in 20% of the data will go as testing and remaining 80% will go into the training. Now, this data, this splitting is kind of random, just that that randomization is based on a particular column's value. Okay. This is the name of the column. Good. Now, since we need other variables from the top, so what we can do is we can select the cell and say run all of the above. Okay, so it will run all of the cells which are above this one. Okay, run cell above. So it is showing the stars. That means it's going to take some time to execute. Okay, so where did it go? Now we can run it happily. So it has splitted the data into two parts, training and test. All right. Our question is, can the seed be specified in this? In this, in this split? In the one that we have created, we are not using a seed here because we are not randomizing it. But in the actual one, it can be. I'll show you. Now, this is a function that is provided by scikit-learn out of the box, and the previous function based on the ID was created by us. Okay, and we could use this function as such. This is the function that is created by scikit-learn. Here we could pass the housing, and we could pass the test size, and we could also pass a random number. You see that? This is exactly your question. Okay, Gopinath. All right, so we could do that. All right, so let's try to see this one. So this one is also working. Okay, this one is basically based on the random permutation, while the one we used was based on a particular column. So what is random? It's just any number. Okay, so when we compute the random number, it could be either absolutely random in the sense that every time you run the notebook or every time your model runs, it will generate a completely random permutation, right? But if you define a state, if you define a initial seed, what happens is the outcome of the random permutation is no longer random. Okay, is no longer random. So that's why we generally specify initial state. So you can define some other state, I could define some other state, and that way we would get a random permutation in the sense that we would not know what will be initially we would not know what will be the permutation, but every time we run the notebook, we'll get the same permutation. Okay, great. All right, so here we're using the scikit-learn's test, train test split. This is also good enough to be used. Okay, now, moving ahead, but this suffers from the problems that we discussed earlier. All right, so if you take a look at the test set, a question from Tanmoy: if we change 42 to 34, will our 80-20 percentage change? No, the percentage will remain the same, just that you will get a different outcome. Okay, I'll show you what it means. So when we say random dot permutation, okay, and we say 4, correct? So let me np dot, okay, so you see that every time I run this, I will get different results. You see that 3021 is generating all the numbers lesser than 4, correct? So every time we are getting a different permutation, right? But if we say specify a seed before this, let me say I'm specifying some seed, say 10. Okay. Now every time the permutations will be same. Do you see that? I'm running it again and again. Every time the permit, if I change this number, I'll get a different one. Okay. So the basis for permutation is coming from this seed. Correct? You could give it a try. Also, if you want to insert a particular cell above a particular this, what you have to do is click here outside the cell and press A. Okay. And if you want to delete anything, let's say you want to delete it, you can just press, you click here and press X. Okay. So A means add append, X means delete. Okay, a question from Gopinath. In that case, you're working on a team project and say you want someone to be able to verify what you have done, you would include a seed. Okay, all right. So let me answer very good questions, actually, both of them, and it's worth paying attention to it. Question is from Gopinath that say you're working on a team project and say you want someone to be able to verify what you have done, you would include a seed. Yes, that's one of the reasons. The bigger reason is that whenever we are splitting data and the model is being run again and again, our algorithm might end up seeing the entire data, right? So we might end up our algorithm might looking at the outcome. So so since if the every time when we are running it, the test data and training set is being shuffled, okay, some of the record which were part of testing data is part of now the training data. So what will happen is our algorithm eventually will end up looking at the entire testing. It's like looking at the answer sheet before solving the problem. Okay, it's like looking at the answer sheet before solving the problem. Instead of comparing answers, we start working towards the answer. Okay, and we're pretty good with that. Therefore, we avoid looking at the data as much as possible, and we try to avoid snooping bias. That's why what we wanted to do is we wanted to fix the permutation so that next permutation is also the same when the model is run again and again. The next permutation will also be the same, and therefore, whatever was there in the test data will remain in test data. Yes. Uh, yes. Thank you, Gopinath. That's the right word. So that we do not end up overfitting our curve. Okay. We will talk about it. We'll talk about it in more details a bit, what it means by overfitting, underfitting, and so on. All right. A question from Noor. So this scikit-learn function is same as our custom function. We already and we already defined the problem with that. Why should we prefer to use this? Yeah. So yes, that's right. So ideally, we should be using this function that we have created. Okay, and we can use it happily. Okay, this is the function that we have created. All right, so we have splitted the data. We can use that one as well. Okay, so we can take a look at our data. Okay, so this is our data set. All right, so we're going to use this consistently for the rest of it. Okay, now moving ahead. Yes. So a question from Kamal is, how could I use scikit-learn train test split and avoid snooping bias? Okay, so the quick answer is no, you can't. And there is already a check-in pending, and they are basically trying to come up with train test split with by ID, the one that we similar to the one that we defined, in order to be able to split the data based on that. Okay, so they basically probably it will come in next version or so. Okay, it's already pending commit. All right, now let's take a look at the next one. And now we have uh, we have splitted the data, and let's create a histogram of our data. Okay, so the way you create a histogram is whatever we basically pick up a column or pick up a parameter. So housing is our overall data, and we are saying medium income, and we are plotting a histogram. Okay, so we could also say train here. Okay, what was that? Test set, right? Train set. Okay, so you can see that this is histogram. Okay, let me just let it be the way it was. I'll explain to you now. So okay, we've talked about these parts. All right, I think this is where we need to start. We'll talk about the histogram later. Till here, we're done here. Okay, now we resolved our issue with something called snooping bias, right? Snooping bias. Now let's talk about another very important thing called sampling bias. Okay, you will understand why I'm talking about it, and you will know that. Okay, okay. Very good question from Kamal. I'll explain to you that. Okay. There was a very a good question. So let me go up. A question from Kamal is that if I want to know the definition of this method called train test split, what would I do? What would I do is I'll just create one more cell here. Import this. First of all, I need to import this and then say help and provide this name of the function here. Okay, so you can see that. Using this, you can take a look at the help. Good. All right. A question from Binta is that can we plot all of the hist columns together in one command? Yes, we can do that. What you can do is you can say housing dot hist. Do you see that? Okay, so using housing dot hist, we can do that. Okay, so yes, I don't need to do that, Kamal. Kamal's question is that why did I need to import? Why did I need to import this again? We don't need to. I just wanted to make sure that um, that one is imported already. Okay, I'm a paranoid person, so I tried to be on the safer side. Okay, all right, wonderful, wonderful set of questions. Now moving on. Yes. So you first need to import the exact function and then say help. Okay. And why do I need to import? Because if you basically the help function probes the actual content of the function. Okay. And the way the comments and the documentation is part of the code, part of the Python code. And that's why it was working. So help function works on an object or works on an instance of something. And that's how it is. Okay, so check with the import. Probably it wasn't done. Great, great. So now we are going to talk about something really important. So just now what we did was we um, we splitted our data based on the ID, based on a particular column, right? Now, next thing we are going to do is we're going to understand how to properly sample the data. How to sample the data so that we do not end up with something called sampling bias. Okay, right now we basically used a random sampling, and random sampling works fine if the data set is large enough. Otherwise, we are at the risk of introducing significant sampling bias. Okay, let us say a survey company in the US decides to call 1,000 people to ask them few questions. What is the approach to pick those 1,000 people? Okay, now mostly we cannot pick 1,000 people randomly. Why? Because the chances are that we would end up with sampling bias. The samples must be representative of whole population. Okay, so there are these three kind of sampling biases. Okay, three kind of sampling biases. First is convenience sampling bias. Convenience sampling bias. What it means is the people who are easily available for your for the giving you the answers, they are their data comes more, right? So you end up with a skewed data of those individuals who were available to give you the answers, right? And convenience bias is quite common. The other is voluntary response. This occurs when the sample have strong opinions on the issue. Okay, say for example, should the West intervene Syria? If this question, the answers of these questions would be biased based on which population do you ask. So the people who have very strong opinion about the matter, they will come forward and answer. The people who have the say the people who have the opinion, yes, strong one, they will come and answer more. Okay. Okay, so what's the problem with the slide? I'm just trying to see what's happening here. Okay, I see. So there was a resolution problem. Okay, all right. Now, next question that I'm trying to answer is that voluntary response, right? Voluntary response. What is voluntary response? Voluntary response is, let's say, I create a survey and I ask a question to all the people that, are you a terrorist? Okay. So of course, even the terrorist will say that, no, I'm not a terrorist, right? So as per the survey, probably nobody will be a terrorist, right? So therefore, uh, when the when the sample you're picking up is having the strong opinions about the matter, you should I mean, if the sample that you have picked up or the and you will also face the situation that if the people with the strong opinions on a topic will come forward uh, would come forward and try to answer it more. So this is called voluntary bias. This is called voluntary bias. Now the third one is non-response. Okay, if uh, if a non-response uh, there could be a population which is not interested in answering a question, then that's called that causes the non-response bias. Now, the to avoid these biases, specifically the convenience bias. Convenience bias is also very common, that whosoever was available to give the sample, we just took their survey, took their feedback, but did not include others. Okay, so to avoid these kind of biases, what we do is we do sampling as in, let's say there is a huge data and we would like to pick the sample of the data. We would do a proper sampling. The first one is the random sampling as in, imagine that you have these data points, these are the data points, right? And you just pick people randomly from this sample set. Okay, so this is the one that we just did by using the previous methods. Now there is something called stratified sample. So what you do is you divide the data set into the stratas, and then the pick the samples from all of the stratas in the same proportion, right? Because imagine that we were having a smaller strata here, okay, and we picked say 30% of the data. There could be chance that this the values of this strata do not appear in the output at all, right? Because there could be a chance that the values from this strata do not appear in the outcome if we are using this mechanism. some of the stratas can be missed. So our analysis will not be all inclusive. We would have left one whole strata completely, right? That's why when we are talking about the economic growth, we always do a all inclusive. We do not just pick a random sample. uh, And what will happen in the random sample, that the many stratas of the society would get skipped. Therefore, whenever we do the whenever we do the sampling, we generally pick, let's say we are trying to pick 30% of the total records. One way could have been just pick any 30% from the whole, right? This is called random sampling. The other is pick 30% from this, 30% from this, 30% from this, 30% from this, 30%, and so on. And this 30% is not same everywhere. We'll say that based on the size of this, we will pick up the ratio. Okay. Okay. All right. So this is called stratified sampling. Okay. Now, this next one is cluster sample. What we do is we create clusters and just pick the clusters. Okay. And then out of the picked clusters, we pick up few. So we divide the population into clusters and randomly sample a few cluster, and then randomly sample from within only these clusters. Okay. Meaning we only picked couple of clusters, and then from these clusters we picked something. Okay. Picked some records. So out of this, stratified sampling is the one which we would follow, because that doesn't lead to the sampling biases. Okay. That in our case, we are going to create we are going to create the housing strata, right? What does it mean? So our housing record basically have the price of the houses and other features, right? Since we are randomly picking the housing record, the chances are that the certain group of housing which are rare might get missed. Okay. We don't want to miss we do not want to miss the extremes or rares in our analysis. Okay. Did it make sense to you? So we are going to go with stratified sample. So far we were doing this sampling. Okay. Is it clear? So as I was defining earlier, as I was defining earlier, um, here, whenever we do not have an all-inclusive approach to the survey or picking up the sample or conducting a research or conducting a study, what we do is we end up with the biases such as convenience bias. Like um, let's say I want to check whether teaching online is a good thing or not. Okay. Teaching online is good or not. So what I'll do is I'll get out from my house, just whosoever I met, first 10 people, I talked to them. Okay. So they said, yes, teaching online is great. So this is convenience sample. Maybe the people who are living in this area are okay with the online because they have connection, and therefore I will always, with my sample set, I'll always be saying that 100% people who participated in the study said that teaching online is great, right? This is convenience sample bias. Okay. So instead of that, what I should ideally do is I should basically I should basically figure out various stratas of the society, and in each strata I should be asking the question instead of just few. Okay, now three questions. First question from Gopinath is is it same as K means clustering? No, we are sampling here. Okay, K means clustering is can be utilized to generate these clusters. You will see that. Okay, you'll see that. K means clustering could be used to generate the clusters. Okay, and then that's like next level of the in the machine learning. Okay, now the next thing, a question from Kamal. We, it seems that we should always use stratified. Okay, generally yes, stratified is something that we used so that our overall research is based on all the records. But is there an example where we don't use the stratified sampling? Okay, so stratified sampling makes sense only if we are able to define some kind of a strata. If we have a picture, if we have a clarity on what strata are we defining, the definition of strata, then it will make sense for doing for us to do the stratified sampling. But there are situations where um, you don't have a clue about what is strata and how do I define a strata. Okay, even like you if you look at the housing data, still we have no clue what is strata here, right? So in those cases we generally end up with random samples. Okay, so the third one is the clustering. A question from somebody is the definition of cluster and strata sound same? Not really. So what we are doing is out of these, out of the first we formed the cluster. Out of this we picked third cluster, fourth cluster, and eighth cluster. Okay, and ignored all of these clusters. Here, from all the clusters, we are picking some percentage from all of the clusters. In a stratified sample, we include all the clusters as part of the work. Okay, and cluster sample is first we pick this few clusters, and then within those clusters we pick some sample. Okay, we pick some sample. All right. Is there a rationale you choosing a particular clustering in cluster sampling? I think it made sense. Did I answer your question, Gopinath? Right. So basically, we divide the data into particular clusters, and we randomly uh, sample a few cluster, and then randomly sample from within these clusters. Okay. So we when I say here, right, randomly sample few cluster, meaning randomly pick few clusters. Okay. Sampling means picking something out of a bigger data set. Okay. All right. Uh, uh, okay. So a question from Noor. This is a very interesting question. Um, that what is the method for creating clusters or strata? Is there not a chance to include the biases while creating a clusters or strata? Can you give an example of SRS? So I think a better answer would be to move on to our housing data set. So what we are going to do is instead of randomly sampling our housing data, what we're going to do is we are going to break down our housing data into different categories. And then, and then, and then from each of the categories, we are going to pick the random sample. All right. So that way, that I think that would answer your question. And you will see that we will also compare with the actual data, the random sampling. We'll compare the two, random sampling and stratified sampling, and then you will get the idea that stratified sample is definitely better. Okay. Now, sampling bias is another example. Is, let's say, US population composed of 51%, 51.3% female and 48.7% male. Okay, a survey was conducted on 1,000 people in the US. Uh, in the US, should try to maintain the ratio in the sample as this to this. Okay, 513 to 487. So um, a well-conducted survey must retain this kind of a ratio, and it should not happen just because a certain part is lesser in the size. It should not get skipped. Okay, so we will use the stratified sampling. If we can define a strata, generally people go for stratified sampling, though in certain situations there could be a need of going with say going with the mm, the cluster sampling, but that's really rare. Okay, when we have humongous data and we know that our data is uniform, then we can create a strata based on a criteria which is uniform, and then ignore some of the clusters and so on. So generally people go for stratified sampling instead of other methods. Okay. All right, this we have covered. Let us say that some of the experts that we asked earlier advised us that median income is very important attribute to predict median housing prices. Then the test set should be representative of various categories of the median income. Okay. So income is as a parameter varies a lot between people. So, and it's a very important criteria. That's what we were told by say other experts who were doing the survey again. Okay, again, what we're talking about our housing prices. One of the attributes in the housing prices is the median income of that district, right? So every record in the data that we're talking about, the housing prices, every record has the housing median housing price of the uh, district and the median income of people in that district, and the various other aspects like longitude, latitude, and other things with respect to that particular district. Okay, so so we figured out that the median income is something that seems to be important, and the test set when we pick should represent the various category from all economic classes, right? We should not be missing out. Sorry. Okay. Hmm. Sorry. So so we should not be missing out on certain districts or certain numbers just because those are rare in the data set. All right. So okay. So let's take a look at how the median income is varying, right? So you can see that when we are plotting the graph here, we are saying housing median income hist. Okay. So what does this hist show? Hist shows the histogram of this particular column. So I'm going to show you this in the here. Okay. First of all, let's take a look at the median income column. Okay. So median income basically contains, this is the row number, okay, and this is the median income in I think 83,000 USD. Okay, this is what it means probably. And here what you see is these are the, basically it's a single column. It's a single column with this. Now, if you plot the histogram, what is it going to do for us is it's going to plot the median income such that on the x-axis it is the median income. It's the income average, or you can say the average income or mean income or median income. So we're going to use only median income. So here, because median income is what is provided per district, so median income is on the x-axis. On y-axis is number of people belonging to that income. So here we are saying that these many people are there, these many people are there whose income is between 0 to 20. Or you can say these many districts are there, these many districts are there whose income is income is between 0 to 2. Then between 2 to 4, you can see that there are between say 2 to maybe 2.5. Here 3.5, here till here. You can see these many people are there whose income is this much. These many people on the y-axis, it's a total count. This is the total number of people. So these many. So you can see that the most of the people have income between 2 to 4.5, right? That's what it is, correct? So those are the observation. Do you see any other observations? What is your observation about the histogram? Balaji, Bintao, Giji, Gopinath, Kamal, Nirav, Noor, Pavan, Pratik, Ross, Shahrukh, and Tanmay. Do you see the, okay? It's actually right skewed. Okay, right skewed because there are a lot of yeah. Okay, and Gopinath says there is a bias through the skewness of the data set. Good, good. Okay, Gopinath, you can answer to all. That yeah. Okay, Kamal. So what is your observation from histogram? I hope histogram is clear to all. The meaning of histogram. Meaning of histogram is basically we are computing how many people are there from that to that number, and we are putting that on the y-axis, right? So we created the buckets and we have plotted that frequency analysis. Okay, so on it's a very common problem which I see is whenever we are plotting this kind of histogram, people forget that who is on the y-axis. Okay, the y-axis this side, this the height of the histogram is basically total number of people, total counts. Here is total districts or blocks. A question from Gopinath: would we normalize the data before training model then? Yes. Okay. What other observation do you have? Most of the population is in which economic strata? Do you see here? Maximum people? 2 to 5, right? So if you see here 7,500 people here and 6,000 here, so this is 13.5 thousand people, 13.5 thousand blocks or districts are here, correct? And remaining say 2K plus 3K, which is 5K plus 6K, and so on. So remaining 6K people, or 6 and 6.5K, is outside, while most of the blocks are 13.5 thousand blocks are here, right? So you can see that most of the values are clustered around $2,000 to $5,000. Okay, and so most of the values are in this. Okay, that means there are some median incomes that go beyond 6. There are some outliers who are basically having a higher income. Okay. All right. So some median incomes go beyond 6. Some median incomes go beyond 6. So since the median income is important attributes to predict median housing prices, it is important to have sufficient number of instances in the dataset from each stratum, each income stratum. Okay, this means that we should not have too many strata, and each stratum should be large enough. So what we're going to do is, first of all, we are going to limit the number of categories of the median income. Let's first of all divide the median income by 1.5 so that we will not have too many strata. Why are we doing that? Since this is spreading too much, so what we'll do is we will divide it by some number so that the total income goes down to say here. Okay, come till here. So instead of spreading till there, it'll come a little till here, right? That's why we're dividing by 1.5. And each stratum will become big enough. So up till now, let's say it's spreading from 0 to 12, or let's say 0 to 15. After dividing by 1.5, it will come till 0 to 10, right? 15 will become 10 after dividing by 1.5, and so on, right? So it'll basically come till here. Okay, so first of all, we are trying to compress the horizontal axis by dividing the mean income by 1.5. Okay, so this is what we're going to do. And second is what we're trying to do. Second is here. We are going to create the categories, a new column called income underscore categories. Okay, based on first we are dividing mean income by 1.5 and saving it income categories. Then we are saying if income category is lesser than 5, set it to 5. Okay, set it to 5. If the value is lesser than 5, okay, then set it to 5. Okay, I'll show you. The next thing we're going to do is we are saying that first of all, compress it. I'll just split it into two parts. Okay. Okay. So first of all, here what you see is we're saying housing income category equals, we are saying divide income by 1.5. Okay. And take the ceiling. What is ceiling? Who will give the answer to ceiling? Ceiling means the upper value, not the round off, the upper value. So when I say this ceiling 1.5, what it gives us is 2. Okay? And if I say 1.1, then also it gives 2. You see that? So that's the ceiling. So while after dividing by 1.5, we are basically picking up the ceiling so that we could have actually picked the round, but it's better to pick the ceiling because all of the values that are divided from a certain number will basically go to the upper side. Okay, so so this is what we did here. Um, this income category after dividing here, let's take a look at how does it look. Okay, I'm just saying hist. Okay, so what is the wrong? Okay, I think I've not executed this one. This is right, right? And okay, let me just see. Is this okay? Okay, now it should work. Yes. All right. So I've run this. I've created income category column. Now you can see that this graph, as we have plotted it here, let me see if I can make it a little bigger. Okay. All right. So you can see that after, did it change? No. Yeah. So from 14, it has come down to 10. You see that? Okay. So we have basically, yeah, it hasn't changed much with respect to shape, but the total values have come down, right? Total values have come down. Okay. Now, next thing we do is we further here, we are saying if income category is lesser than 5, right? So all of the people till here, right? We are just putting them in same bucket. Okay, same bucket. So now if you take a look at it now, it'll look like this. Okay, you see that? So basically, what we have done is all of the people till 5, okay, if the income category is less than 5, we have put the value as 5 and we have said in place equals to true. Okay, now we can take a look at we can take a look at the number of values in this. So these are the fixed values. I think you are right. It should be, yeah, that's what I've been also wondering for some time. I'll try again. Hmm. So Alex, I think there is a bit of confusion here. Hmm. Let me try again from the beginning. So first of all, we created this column, then we plotted the histogram, then we did this. Okay. All right. So this looks better. Now, so it should be here. What we're saying is that if the income is lesser than 5, okay, so all those columns for which the income is lesser than 5, we are setting it to 5, right? While there is, I think there is a confusion somewhere. Okay, so yeah. So basically what we are doing is so it's very clear to me that what we are trying to achieve here, what we are trying to achieve here is this. We are trying to make this strata that look like that look like equally sized one, and we are able to achieve it. It's just that the reasoning is not clear here. Okay, the value of the income category should, for less than 5, we are setting it as 5. Okay, and so on. Okay, all right. Let's take a break, and after the break, we can continue from here. So I'm back. Should we start now? Great, great. So what we are trying to do is we are trying to break down the values into the multiple buckets. Okay, so that we can create the stratas. That's what we are trying to do. We are trying to create the stratas. The first thing we did was we divided the actual value by 1.5. Okay, is everyone back? Should we start? Okay, just give me a second. All right, so let's start. Let's start. Um, so the first thing we did was we, first of all, kind of instead of having such a big range, we broke it down into like we divide by 1.5. Okay, that's what we did, and then we created a new column. If after that, and one more thing we are doing that we're skipping again is ceiling. What ceiling does is anything between, say, 0 to 1 will become 1. Anything between 1 to 2 will become 2, and so on, right? And anything between 3 to 4 will become 4. Anything between 4 to 5 will become 5. That's what ceiling will do. Okay. And here, after doing this, when I say value count, you can see the value counts. Value counts is basically frequency computation of each number. I'll do that in a minute, Gopinath. So what you see here is, so I'm breaking down that strata computation. First of all, what we did was we divided the range by 1.5, and then we computed the ceiling so that we get buckets. This is where the bucketing is happening because of ceiling. And then we said value count. Value count, what it does is it displays you the frequency of various numbers. Okay, so it is showing that 3 has occurred these many times, 2 has occurred these many times, and rest beyond beyond 5. Um, Beyond 5, it's the rest. You can see that these are the numbers. Okay, so this logic, particularly this one, is going to add these values. Okay, these values into this. Okay, into this. No, let me just see what happens in this case. All right, so let's see the value counts. Okay, so what has happened is 3 remained as such, 2 is here. So 1, 4, 2, 3 is summed up with 6, 7, 8, 9, so on, and it has become 2, 3, 6, 2. Okay, okay, let me show you again what I mean. Uh, Here we are doing the value counts, you can see. Okay, and what you want to do is anything bigger than 5 should become 5. Okay, now this is the only piece I have a bit confusion that it looks a little counterintuitive why it is happening. So let me just try if this is the case. And if I run only this piece of logic, what happens, right? So, just a second. What is wrong with this? Okay. All right. So for now, let's just see that these values will get summed up. All of these will get summed up into 5 once we do that. And how it's happening is we are passing this condition, which says that income category less than 5. For some reason, it should be greater than 5, but this is how it's working. Okay. So let me just try again from this is good. I'm quite convinced it is this way. Okay, so far so good. So these are the value counts of everything. So this is where the bucketing is happening. When we say ceiling, it creates buckets. And then when we say value count, it's doing the count. And once we do that, here, if we say greater than 5, okay, greater than 5, okay, so let's see the value counts now. Actually, it has skewed it too much. It has skewed it too much because it has summed up all the values from 1 to 3, 1 to 5 actually. This one has worked in a wrong direction. Okay, so this is the correct way of labeling those greater than 5 as 5. Okay. For whatever reason, I'll have to take a look at why this condition works in this way. Okay. So in such cases, we can take a look at, say, help of this documentation. So it's a where method. Okay. And what we are doing is we're passing the value as the second argument, condition, scalar in place, access label, and okay. All right. So I see. We could also do this, right? We could also do things like, okay. Okay, for now, let's just assume that this is working fine. Okay. And I can't somehow let it go. Okay. Okay. Now, so the thing is that this condition basically is saying that all the values which are above 5 would be marked as 5. Okay. And how do we make sure that? So this one created the value counts like this, meaning there are these many people whose income is between 2 to 3. There's these many people whose income is between 1 to 2, and these many people whose median income is this much. And when I say people, it's actually the blocks. So these many blocks have income between 2 to 3, and these many blocks have between 1 to 2, and these many blocks have income between 3 to 4, and these many blocks have value between 4 to 5. Okay, and these many values are into 1. Okay, and these many values are there in 6, 7, 8, 9, 10, 11. Now what we want you to do is we want to take these values, put them into the bucket 5. Okay, and the way to do it is using the where clause. We are saying where this condition is true. Okay, so select those records which have this, and in case, I think in case things are greater than 5, put this value. That's what it is doing. Okay, and we are just saying in place. So basically here we are saying everything that's not fitting this criteria should be set to 5. Okay, that's what is happening here. So probably Gopinath's way of looking at it is correct. I think the condition is read as limit the categories to lesser than 5. So it automatically bins the values greater than 5 to the ceiling of 5. Probably that's how we have to read the where clause. Okay. So here we are saying that let these categories be as such, and remaining ones put their values as 5. Once that's done, the value count, you can see that now there are only total 5 buckets. So we just created a total of 5 buckets. Okay, a total of 5 buckets, and these 5 buckets contain kind of good distribution. Okay, so once you draw it, you will get a similar picture like this, the counts. Okay, so you can see that it's a clear, it's a good stratified stratified data. Now we can apply the, we can on this category, using this category, the one, this is a new column that we have created, in which please note that we are have created a new column. We have not touched the income original column. Okay, we have created a new column here. All right, so now here, okay, now here what you have is the from the next is okay, so far what we've done is we've created stratas. We've created those circles that we drew in the chart. Now the next thing we're going to do is we are going to use something called stratified sampling or stratified split to pick a percentage from these stratas. Okay, so we are importing this method provided by scikit-learn called stratified shuffle split. So we are saying number of splits is 1, okay, and the test size is 20%, and the random state we are passing the seed as 42, okay, and here we are saying that first, we created the instance of the split. We first created the instance of split by passing various parameters to it. Parameters like how much percentage do we want, and the random state, and the number of split that we want to create. Then we called this function, this object's function called split on the original data housing, and it specified that the stratified sampling should happen on this column. Basically, the second argument to this function is split. The second argument is the definition of your strata. Definition of strata in your data is what is the second function, second argument. And here, once it does that, it produces a list of tuples. This split function produces the list of tuples. In our case, it's just 1. In our case, it is just 1. All right. So this is the training. So out of this, we get the training index, which is the index of the values for training data. And this is the index of values for the test data. These are basically list of values, list of indexes. And using this, we access the original data. So split generates the locations of the record, and using those locations, we access the actual data. Okay. What does it mean by number of splits? Right now, we are just dividing the data into 2 parts, test and train. Okay. You could be dividing it into multiple ones. Okay, is it clear to everyone? Now, once we do that, you'll notice that okay. All right. So once we do that, what we have is, okay, and just a second. A question from Gopinath from help. Split number of reshuffling and splitting iterations. Okay. All right, so good. Now, once we have splitted it, since in our case it's only one split, so it's going to be only one iteration, and therefore we are going to get our training and test data set. Now let's try to understand whether this splitting is any good or not. Whether we really splitted the data based on stratified sampling or not. Okay. All right. Good. Next, let's move on. So once we are done with the stratified sampling, what we can do is we can also compute how well we are doing by computing the probabilities. Okay, so you can I'll show you this part. So if you take a look at, this is our test data. Okay, and the let's see the distribution of values. Okay, so you can see that 35% values are in 3, 31% are from this strata, and 17% here, 11% here, and these many percent from first, which means the from every income strata we have certain percentages, and these percentages are proportional to the the actual size of every strata. These percentages should be proportional to the size of the strata. Okay, so most of the people are in 3, therefore we got 30%, 5% of them, and so on. But all right, and so in the similar way, on the full data set, we could take a look again, and with respect to the whole data set also, we have a similar distribution. If you want to compare whether we are doing good or not, we can just write a similar function here. We could write a similar function here. So here we are splitting the data using randomized sampling, using the standard function, right? This is our standard randomized sampling, and this split is basically based on the first approach in the diagram. Okay, and then what we are doing is we are computing the here we are creating the data frame. Okay, where where we are displaying housing for proportion as well as stratified sampling proportion, stratified test data creation, you can say that. And this one is the overall, this one is the random one. Okay, and this one is the one that we have created. Okay, so I think let me just show you the output first, and then we can work backward. So after sampling, these are the population, you can say uh, the percentage of the population we have picked. So overall was how much? So these many people were there in 1, these many people were there in 2nd, these were the overall. And after splitting using random way, we got 4% people from first, 3.2% from second, 3.5 from third, and so on. Now the stratified sampling, you can see, is very close to the overall. Okay, here you can see that even though it looks nothing, but there is a huge difference, and this one is definitely a big difference. Okay, so this table, let me describe this table first. This table compares the two approaches. First approach was just split the data based on without any values, just split the data randomly. Okay, and second approach was to create stratas and then see create stratas and pick the values from each strata. The agenda is that the data that we are picking, or the the sample that we're picking should represent every strata in the same proportion. Okay, so so which one do you think is better? Which one is do you think is doing better here? Here it is showing us that overall so many such a, I mean the 3.9% people, 3.98% people of the total are in one, 3.188 are in two, and 35% people are in three, and so on. While in case of random, after we picked up a random sample, these are the percentages of people from every strata, and third one is basically saying that these many people are uh, this is using stratified sampling, that these many people are from first, these many people are from second, and so on. So my question to all of you is, which one out of random and stratified looks good to you? Right? Why? Because if you compare this with the overall, okay, overall, this much is the error. If you compare this with overall, this much is the error. And you can see that random sampling of overall sometimes is missing 5% over the overall ratio. Okay, you can see it clearly here. And that's what we are trying to compute here. This table is what we are trying to represent here. Okay, so first of all, we created a data frame using these three columns: overall, stratified, and random. These three columns is what we have first created by using this function called income cat proportions. So first one is for housing, second one is for stratified sampling data, and third one is for the test data. And afterwards, we added two more columns, the errors and the stratified data. Okay, what does it mean by negative error? As in when we are subtracting, here we are subtracting the value from overall. Okay, that's fine. Okay, so the way we are doing is here we've defined a function called compare. Okay, this is good. And we are subtracting that from 100. Okay, the negative means we have picked that less than less than the actual one, and positive means we have picked more than the one. Okay, had there been zero error, that means our sampling is just perfect and is same as the overall. Okay, negative and positive both means wrong. Okay, whether we have picked 5% less elements from this particular group or 4% less element in this particular group in the random sampling, both are wrong. Similarly, 1.7 more than actual one is also wrong. Okay, so what we understood just now. Okay, so what we just did just now is we compared the two approaches, random and stratified. And basically, these are all parts of statistical inference. And we're learning statistical inference as we are doing the project. Okay, that's why it's going to take a bit more time the first project that we do together. Okay, instead of had I been talking about the stratified sampling in the air, this wouldn't have made sense to you now, right? I hope this is clear to everybody, the stratified sampling. Okay. All right. So by the end of this project, you will be thorough with most of the ideas about statistical inference as well as the data science. So whether we call it analytics, whether we call it uh, predictive analytics, whether we call it data science, it is this what we are doing right now. Okay, it is this what we're doing right now. All right. So it's definitely a very, very important thing to do. And there's a very interesting decision that we took, that we will start with the project rather than going with the theory. All right, good. So far we are good with creating the stratified samples. Okay, so we have created train set and test set. That's the overall outcome of this one. All right, and for everything afterwards, we are going to use this train set. All right, we are not going to touch the test set. So we're going to train ourselves on the, we are going to explore the stratified training set. All right, that's why we are copying this into this. Why we are copying? We could have just assigned it, because if we make any changes to housing, it's going to change this. All right, so good. All right, this is what we've just discussed. Okay, so yes, I'll come back to that. That's a very good question, Binta, because we don't need a strata anymore. After we have picked the data, we don't need a strata. Therefore, we are dropping that column. Okay, we have clarified this one. This one was basically, our assumption was right, that wherever this condition is true, don't touch anything. Otherwise, set 5 if this condition is not true. Okay, so our understanding of the where clause was limited, uh, and therefore we were not able to explain it properly. So basically, it was the syntax is, where the condition is true, don't touch it. Otherwise, if this condition is not true, meaning there is something that's lying beyond it, put this. Okay, it's like saying select star from something. If there is null, put some value there. It's like that. Okay, now we have explained it well, that each stratum is large enough and there are too many stratas, right? There are not too many stratas. So we have broken down into few strata, and each strata is large enough, right? You can see that there are no strata is like very, very small. So this is good enough. And by plotting the data, this you can see it better. Okay, then we did this, and did it work? Yes, it did work. So we compared the two, the stratified sampling and this, and then we did a proper comparison here. Okay, so observation is that it's actually the stratified sampling is doing good. All right. Okay. A point from Noor, but this is contrary to normal way it works in other language. That's right. That's right. Okay, good. Now, so now we are dropping this category attribute, the strata. We don't need it anymore from both of the training as well as test data set. We are deleting this particular attribute. Okay, we don't need it because we are done with creating our test set. All right, and we don't want to touch this because this is not our input parameter. This is a input parameter that we have created, and it lacks a lot of information because we have cut down on we have converted a big value into a small value. Therefore, this is not going to be used in the machine learning. Okay, therefore we need to drop this. All right, so why did we spend so much time in test generation? Test generation is often neglected, but most important part of the machine learning. So now let's move on to the third step. So second step was really big. Getting the data was actually the big one because we learned many new aspects. We learned the statistical inference, we learned the analytics, and so on. Okay, now moving on. So let's explore the data to gain insights. So test set we have kept aside. We are going to use stratified train set. Okay, in order to make sure that we do not look at the test set. We will talk about test in the end. In the end, when everything is done, we have compared the algorithms, we have done everything. Only then, on the last step, we will run against the test. Okay, till then, we will just explore only the training set, that too the stratified training set. So if the training set is large, we generally sample the training set to make manipulations easier and faster. When we say, I mean, if it's a really huge data, like in terabytes or something, then what we do is we create a sample training set. Okay. And to make the manipulations easy and fast, and we can visualize and discover the data. Since our training set is small, we can directly work with full set. Okay. So here we are just going to work with, we're going to just work with this data. All right, this data. So what we've done is we have copied it to the housing. Okay, now so this is our data set that's going to be, and we are going to just take a look at the data. Here what we're doing is we are plotting the scatter plot. So you can see here this same data we are plotting using housing.plot. Okay, and we pass the we tell the what kind of plot do we want. Right now we want a scatter plot, as in when the need arises we'll talk about other plots as well. Then there is the x-axis is longitude, y-axis is latitude. Okay, now this doesn't look really nice, right? We can't figure out the density really well. So what we do is we are going to put an alpha. Alpha sets the transparency. Alpha sets the transparency of every element. Okay, now you'll see that. So every element's transparency is set to 10%. Okay, and this is how it looks like. So we are saying housing.plot kind is scatter, x is longitude, and y is latitude, and alpha is zero point 0.1. Okay. A question from Tanmay: what is the practice of big data like Spark to use full data set or sampled one? So good point, very good point. You have asked the question at the right point. So um, if the training set is large, really large, so what we do is we sample the training set. Okay, why do we do that? Because I'll give you an example of, say, what we were doing at earlier at InMobi, for example. Our data set was around 200 terabyte, as I was explaining earlier. So there, what was happening is, since the data was really humongous, we were not able to focus on the problem. We could not analyze the data manually. So what we did was we first of all used our big data tools to do the sampling for us and give us a smaller sample which we can analyze on a local machine. And afterwards we once we were done with experimentations and building the model, then we we basically deployed those algorithms on on the big data platforms. Okay, so using Mahat and others, once we were done with the smaller sample, then we deployed it on the real data and the bigger data. Okay, so that is this sampling is basically a big data process, meaning sampling is run on multiple machines and it gives us the smaller records, smaller set of records. Okay, so that's how it is. A question is, this looks like California map. Yes, it is California map. Okay, so coming back to the scatter plot. So we are able to do the scatter plot. So here you can see that the population is higher here. Why? Because we have put the alpha as 0.1. Alpha 0.1 means we have set the transparency of every point to 10%. Okay, that also means that when multiple points come together over each other, it'll look more dense. That's why it is showing you like a heat map. Okay, so this is also called a heat map. Okay, heat map is the map of where the temperature is higher. Okay, so now there are a few more parameters that we are setting. We are setting longitude, latitude, the transparency. We're also, passing the parameter for the scale. Okay, this is where we are passing the scale, and okay, and we are also setting this figure size, and all right. Now there is a color. So here we are setting the color. Here we are setting the color in the sense the color is a derivative of the median house value. The median house value. Okay. So the size of each circle is the population. X-axis is latitude, longitude. Y-axis is latitude. Sorry, X-axis is longitude. Y-axis is latitude. Okay. We have set the transparency to 40%, and we are saying that the size of the circle should be the population, a function of population, and the color of each circle should be based on median house value. Okay, and right, and we are saying that use this color map called jet. Okay, this is basically this is that color map that we're using, and we are saying that show the color bar on the right hand side, and share X means basically fixes the display bug. Okay, where the legends are not displayed. So that's why we are using the share X equals false. Okay, now that essentially means, okay, that essentially means that it's going to display the uh, entire plot. Okay, we go one step further. What we do is we set the California image in the background. We put the labels more clearly, and we also put the labels by you know in this way. Okay, we've put the labels on the legend also. So all of this is very customizable. Okay, so you can see that we have been able to plot it as if it's a proper map. Okay, okay, so probably let me try again if the scroll bars are not there. Okay, so this is how it looks like, right? So what we have done is we have put a background image of the map and so on. So now you can see the patterns really well. A question from Noor is why even use the scatter plot like this in a hard way when you have tools in Tableau? The Tableau ways will be really long. Okay, this is for visual analytics. Tableau is for sending the reports and showing to the reports. Here it's extremely customizable because it's programmable. We can plot this one by a dynamic data from our own code. Okay, so that's why so matplot is something that you can take a look at it, and we will keep on using various libraries of matplot, and you must explore the library by yourself. And I think the best way for learning the matplot library would be their documentation. And as we do the more exploration on the visual side, we will basically learn like the way we learned hist, the way we learned plot, and so on. So we will whatever we are learning in the as part of project, that will be more than enough for most of the works. Okay. Question is how can I see the parameters of this? So generally the if I say housing dot plot here help, it should generally show you. Okay, so you can do line, scatter, and so on. Okay, so after importing it, you can take a look at it. All right, now coming back to it. So basically when we are plotting a graph, generally we don't have to be so sophisticated with the graph here, since we wanted to show you in a very nice manner. That's why we have kept it this way. Okay, while for our own analytics we will generally not put the too many of the legends and all of this. Okay, so I hope everybody is able to plot the map. No. Okay, great. Only Gopi is able to do. What about others? Balaji, Mintao, Gigi, Gopinath, Kamal, Nirav, Noor, Pavan, Pratik, Saruk, Tanmay. Okay, I missed the question. Question from Kamal is, the plot of 24 only indicates that we have more data points of those areas which are darker. The plot of 24, which means, okay, actually for me the numbers are different. So do you mean this one or this one, right? So this one represents that these are darker. Why? Why and how? Because what we have done is we drew these circles. We drew these circles, correct? And these circles were overlapping each other, correct? So, and while overlapping, since we have set the transparency to say 10%, and when there are multiple things and they are partially transparent, the areas where they're overlapping, it becomes denser. That's how it is. Okay. So if we let's say in the let's say in the Google presentation here, if we say draw something like circle like this, and I'll just show you what I mean. Okay. All right. I'll just show you. Okay. So here, if I let's say here, right? I set the transparency of this block as something, correct? So, okay, not here. It doesn't have the formatting. Okay. So this doesn't have the transparency, so I could show with some other tool. Anyway, so that's the basic. Oh, what happened here? Okay. So basically, whenever we have whenever we are drawing something and they are transparent, when we translucent, not transparent, translucent, and when we put them over one another, it generally creates this darker side. Okay. It just shows that there are more data points on this side than this side. That's what it shows. That's right, Kamal. And okay. And good, good. The, Without, does that answer your question also? Okay, wonderful, wonderful. So all of you are able to draw this plot. A very good question from Kamal, that why didn't we do stratified sampling based on the location too? Good point, good point. So yes, so there was this insight question that we started the discussion with, that we were told that the income of people is playing a bigger role in the that was a insightful information that we have received, but ideally we would like to do that also. Okay, we would like to do that also. And right, so we basically considered the outliers in terms of the economic disparity instead of the geographical disparity, but the taking the location also into part would be a important decision to do. All right. Okay, so that also is another general criteria which people choose for sampling. Okay, now coming back to the point. So all right, so good question. Good question from Gopinath. Gopinath. So let me again clarify Kamal's question. Kamal's question is, why didn't we do the stratified sampling on location, right? One should do, and that's also one of the criterias for proper sampling. Okay. Second is from Gopinath, that what if we had to do on both? Let's say we want to do the stratified sampling based on two parameters. So answer is simple, that we prepare a third parameter by combining the other two. Okay, we say that the column y equals column uh, A plus column B, or multiplied by column A into B. So some form of formula, using formula, we create the third parameter, which is a function of the other one, which is derived from the other two. And then we can do the same thing what we have done for the category attribute. Okay. Very good set of questions. Keep the questions coming. Okay. All right. Yes, create a column by combining two columns, right? We can always do that. We can create by composing like a composite column. All right. So this is where we are. What are your observations? What do you observe here? Anybody? So we are able to plot the population and the prices here. So bigger the circle, bigger is the population. Red dot means the real estate is costly. The blue dot means real estate is cheap. So red dot means you can see these areas. Here the real estate is costly. Here the real estate is costly. While the blue ones means it's really cheap. Okay, this is really cheap and so on. Now, a question to you is that what are your observations on this? Yes? Tanmay, Pawan, Noor, Pratik, Shahrukh, Nirav, Kamal, Gopinath, Giji, Bintao, Balaji. Okay, so that's interesting. So real estate looks costly near the shore. Okay, okay. All right. Okay. All right. All right. Good. Good. This is something that you will notice that how deceiving are our senses. Okay. So yes, it looks like the other criteria. Kamal is hypothesizing that there could be an airport or port there. That's why the real estate looks costly at these areas. Okay. All right. So let's take a look. First observation is yes, that these two locations which look really red, the the cost is higher there. So the observation is that house pricing are high in the high density area and those are closer to the ocean. Okay. Now my question is, what about these areas? What about these areas here? They are also close to the ocean. They are also close to the beach, and maybe they should have been expensive. Why aren't they expensive? Okay. So in North California, the house prices in coastal districts are not so high. So it's not that a simple rule. Okay. So it's not a simple rule to just follow. Okay. And Pawan's point is that these are not in the cities. Good, good. So the second criteria is the cities. The other criteria is the facilities and lack of job, quality of education. Yes, those are the criterias that we need to consider. Okay, not only the closeness to the seashore. Good. So therefore, so all of you got it right. So therefore, we cannot simply say that something closer to the sea, the cost is going to be higher. Okay. So let's take a look at the other parameters. Let's try to find out uh, a stable way or a predictable short way of forming the correlation. Okay. So let's try to understand what it means by correlation. Correlation indicates that the extent to which two or more variables can fluctuate together. Okay, so you can see that this one is a perfect correlation, perfect positive correlation, as in when x increases, y is increasing. When x is increasing here, y has also increased. Similarly, x is increased and y has also increased, x is increased, y has also increased. This is a positive perfect correlation, right? Here, this one is a high positive correlation, meaning there is a strong correlation, just that it is not perfect. It is not perfect because it is little scattered. This one is low correlation, low positive correlation, because it looks very spread out. No matter which line you draw, there are going to be errors in this. Okay, and this one doesn't have a correlation. This one does not have a correlation at all. This one is a negative correlation, as in the as x is increasing, the y is decreasing, y is going down, right? So as x is increasing. Similarly here, this is high negative correlation, and this one is a perfect negative correlation because it looks like a line. Same thing has been demonstrated here, that when the same thing has been demonstrated in a single chart here. So this is positive, negative, perfect, and low correlations. That's what we have learned. Okay, so the way we another strategy that we apply, we try to measure which column is varying with which other column. So what we do is we take one column and plot it against every column. Okay, that's the correlation method. Okay, just to understand the relationship if relationship with the actual data. Okay, so a question from Tanmay, that what is covariance then? I'll come back to that later. Okay, so yeah, all right. Great. Now, so let's take a look at this one. Let's take a look at the correlation. How does it look like? Okay. So when I say correlation matrix like this and just sort the values, it is an interesting phenomena. It shows us that we are telling that, so correlation matrix is a huge matrix here. Okay, I'll show you the entire matrix and that will make more sense to you. You can see that we have figured out the correlation of longitude with latitude, longitude with longitude, latitude with longitude, all of these. Do you see that? Against every record. And of course, why is this one? Because it is increasing by itself, right? Therefore, the whole diagonal is 1 because we are computing the correlation with itself. Okay, the correlation with itself is always going to be 1. Okay, so using the core method, we prepared every column's relation with every other column. Okay, every other column. So here it shows that um, the the latitude and longitude have a relationship, and this value and this value is generally same. Okay, this value and this value is going to be same. You can see that because the relationship between house median age with the with say longitude versus house median age and longitude versus house median age. So it's basically it's a matrix which has all the elements on the right hand side of the diagonal is same as this one, because if x has a relation with y also has a same relation with x. Okay, so you can see that against every attribute is what we have plotted here. So you can see that there is a strong relationship with the longitude latitude. No, it's calculating for all of the attributes. Housing has these many attributes: 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 by 10, meaning these are 100 cells. Okay, yes, they are symmetric along diagonal line. No, it's calculating for the entire data set. We had deleted, yes, you are right. We deleted income category. Why did it come here? That's a good point. Thank you for that observation. Okay. Yes. Oh, did not. Oh, we did. I did not execute this one. I see. Okay. Now it's gone. Thank you. All right. So basically, this core method is really cool. It computes the correlation between every parameter with every other parameter. Okay. Now we're going to now just to take a look at the say only one variable. So we're going to just take a look at the relationship of the correlation with median house value. This is what we want to figure out, right? We want to figure out the how is the median house value related with others. The rationale behind income category is that income category was a derived column and does not have much of a value other than creating a strata. Okay, we don't want to base our judgment based on the income category. Okay, if there was a relationship between income category to any other thing, we could actually use that with we could also get the same thing with the income median income. Okay, okay. So Gopinath's question is why did actually that population per household is being used later. So probably you executed the entire run all instead of run all above. Okay, that could be one of the possible reasons for you getting one more variable. Right? So great. So what we see here is when we just take a look at one of the columns, right? The median income, this one, you will see these values. If we order this properly, we'll get a better result. So you can see that here there is a correlation between median income and median house value. Do you see that? There's a correlation between median income and the median house value. Okay. Also, there is there's a slight relationship between latitude and the median house value. Though it's negative, but it's still a correlation. Okay. So these two have good relationships. So our median house value seems to be depending on the median income in California, in the various blocks in California. Okay, so now what we can do is we can, okay, so this is a positive correlation and this is a negative correlation. Okay, negative means it's going to decrease as we go up. Okay. All right, so Tanmoy's observation is that the total room and total bedrooms dependencies differ. And you will notice as we go ahead, we will notice that there are quite a few interesting things ahead. Okay, so There's a scatter matrix function which does a very good thing. What it does is plots the plots the relationship graph between all the attribute. So here we are saying pandas plotting, and we are importing a scatter matrix, and using a scatter matrix function, we are calling we are calling scatter matrix over these attributes. Instead of calling on all attributes, we're calling only on the subset of this data set. Okay. So what you see here is when we draw that, this is the only one that seems to make sense. So what it has done is it has plotted all of these four variables against these four variables. And since it doesn't make much sense to plot a graph against its own value, in those cases, it has plotted the histogram. In those cases, it has plotted something useful, which is histogram. So you can see that there is a relationship, there's a positive relationship between the median income and median house value, right? So the scatter graph is very useful when we are trying to figure out the patterns in our data. Okay. All right. So this is the another tool called scatter matrix. It is a very useful function to plot every attribute against every other attributes. Okay. Okay. So since there are 11 attributes and we would not, I mean, we don't have a place for 121 charts. Therefore, we are using only four of these. Okay. But we can use all of them as well. So the first thing we did was we've used the correlation method, CORR, to just take a look at the data quickly. And then we have used scatter matrix to plot the relevant attributes against each other. Okay. So this is how it looks like. This is how it looks like. And okay. So from this, what do you conclude? What is the most promising attribute for discovering the median house value? So rooms per household is not there in that column. Okay. That column is not there yet. That column we will create later. So median income is yes, that's right, Noor. Okay. So these two charts are same thing, because here we are plotting on x-axis the median income, on y-axis the median house value, and here on x-axis the median house value, on y-axis the median income. These two are same thing, just the axes have been changed. So you can see that the house value increases with the median income. Okay. So Noor's suggestion question is, why are we missing the house area? So if you'll take a look at this, the house area is it provided? No, right? I think house area is not there in this. Yeah, it's total number of rooms, total bedrooms, and so on. Okay, so that data point is not there. So the most promising attribute is median income. So we can take a further look again at the same data. So now we are now sure, we are doubly sure that this one is a very important attribute. So we can just plot it using housing.plot. We can do a scatter plot and we get a good graph. We get a good graph here. Okay. What are your observations on this, everybody? What do you think about this graph? Okay. Question from Noor is that what about negative correlation? We did not plot that. Basically, negative correlation was the same thing. Sorry, the negative correlation was there. Okay, which one? Do you mean this one? Latitude versus the median. I see. This one, right? Latitude. Yes, yes, we could do that also. But let's explore one variable once, and then we'll talk about this one also. Okay? Yes, very good point. Very good point. Okay, so yes, since we also realized that there is a relationship between latitude and the median house value, and we're going to talk about it a while later. Okay, let's just pick up the first variable that seems to be most promising and do a little bit analysis about it. Okay, so Kamal's suggestion is it's increasing linearly. Pratik is saying that it is positively correlated. Okay. Gopinath is saying it's a weak positive correlation at the higher house value. Okay, okay, towards this side. Okay, interesting. Pratik is saying it is capped at 50,000. Good, good. That means all the values above 50,000 have been brought here. That's why there is this strange graph here. That's the reason why you see this strange graph. Positive correlation means when one thing is increasing, the other thing is also increasing, right? So when the median income is increasing, you see, if you think of this as a line, then this is also increasing. That's a positive correlation. Okay. All right. Now, so there was a couple of observations, very good observations from you. And one of them is that the values are capped, meaning all the values, there is no value above 500,000. Okay, so so the other thing is there are three horizontal lines. You see these three horizontal lines? They are also kind of noise in the data, just like capping. Okay, we should remove the. Okay. Okay, so I think we are close to the end. So I think we will stop here because some of you might have another meetings or works. Okay, we'll continue from here. And my request to all of you is that go through all the steps, try to explore it by yourself, try to um, run all of this together. Okay. So we will go into more maybe in the next week. I think it is going to take 1.5 more sessions, this project. And this project is very important because these are the things that takes like whole course to learn, but we are doing it in a way that you learn it in a stable way and we don't forget these. Okay, that's why we are taking it through a project. All right, so 90% of the Kaggle competitions would be like this only. If you plan to get into data science, if you plan to get into the career in as a data scientist, I would request that I would suggest that you should start working with some of the challenges, and you'll notice that it's a standard classic project what we're doing, and we could actually team up in the class and solve a couple of challenges. The best way to enhance your career is probably not by alone by certifications, but by learning things or competing in the public forums. And the Kaggle is something that I target for my students, and you will be able to definitely do well there. Okay, so if you want to team up, feel free to team up, because that's the way you can learn really well. Jupyter is not only for education, it is used eh, used a lot in the production environment as well, because it's doing the actual weightlifting. Okay, so yes, Jupyter is for production. All right, for most of the data exploration, data science, analytics, machine learning, deep learning, Jupyter is what we use. Okay. The notebooks are real. People used to use our notebooks. Now we have Jupyter notebooks. All right. So great. Great to have. Yes, it is quite handy. And I'm realizing now. Question is, what is data science? Data science is statistics, analytics, machine learning, and deep learning, along with the big data part. So data science is really a huge subject, and probably everything to do with data is part of data science. Okay, great. So we are learning just in a right way. Okay. Yes, we have a session today in the evening regarding the Scala and Spark on the big data. All right. So yes, see you tomorrow. Not tomorrow, next week. And in the evening, some of you are also attending the evening classes. Okay, thank you so much. And I hope that this will add a lot of value in our careers. Okay, thank you, everyone. I look forward to see you next week. Till then, goodbye. All right, bye-bye, Kamal. Bye, everyone. I look forward to see you next week. Yes, see you tomorrow morning for you, Vidya. Bye-bye. Yes. Okay.